Okay, uh, we are starting now with the data analysis. Like I said yesterday, we'll be looking at NumPy today. So, I'll be sharing my screen and also we start illustrating what we can use with NumPy. But before I share my screen, NumPy is actually used NumPy is used as a framework in Python for array manipulation, array vector matrices, and polynomial. So is a scientific package that we use for solving problems that have to do with arrays, has to do with matrices, has to do with vectors. The next package we'll look at, which is Pandas, is built on NumPy. So the knowledge of NumPy will also be very much valid when we come to Pandas. Now I'm trying to start up my Jupyter notebook. So once I start up my Jupyter notebook, we'll proceed. I'll share my screen and we'll proceed. Right, from yesterday's teaching, we were able to solve any problem. Remember yesterday we looked at basics of Python. We looked at the for loop, the ifs, and also looked at the while loop. So I don't know if you lay your hands on any problem yesterday, if you attempted any problem to solve any problem. If you do, you can just share your experience with us. Okay, we would like to welcome Mr. Nobu and also Mr. Ahmed. We'd like to welcome you. Please, let's hear from you. You can mute yourself and let's get your experience. Yeah, good morning. Okay. So you're welcome, Zoom City. Okay, so we'll proceed. My Jupyter notebook is opening. Okay, let me share my screen. Like I said earlier, we'll be looking at NumPy today. Yesterday we looked at the basis of Python and we were able to solve a little problem with Python that has to do with both decision making and repetition. That is if and loop. That is for loop. We used the for loop yesterday. We used the while loop. So we present today Jupyter notebook. Actually, what we are learning today can be done with the normal Python IDLE, like the default editor. But I prefer using Jupyter notebook because of the fine presentation of its outputs. Jupyter notebook is a platform that is built on IPython, and if you can see my screen, you are being presented with the interface right now. It works with the browser. works with the browser, but it is built on IPython. Okay, to open a new file, I'll come to the new, add this new here. Please just confirm if you can see my screen. We'll proceed. Please confirm if you can see my screen. Okay, so we click on new. Okay, thank you. So click on new, then click on Python 3 to open a new IPython notebook. Jupyter notebook, the extension is always IPYNB, which is Interactive Python Notebook. So as it opens, we start with the process. Now, yesterday we looked at array list, which is also called an array. So we looked at it and we were able to know that array is same thing as list, just that in Python, array is called a list. So what we're doing today is based on array, which is still list. So these things we'll do today can also be done with normal Python, but it will be very tedious. That's why we have NumPy. That's why we have NumPy. So I can just come here, change, save my file, data analysis with Python, the 2. So I rename the notebook. So for me to make NumPy available, I have to import it. I have to import my NumPy as I'll give it an alias, and the conventional alias that is given is NP. I will import my NumPy. So at this point, if you are using another editor other than Jupyter Notebook or Anaconda, you might find out that your NumPy is not installed. It's not pre-installed. So all you have to do when it's not pre-installed, you do pip install NumPy and makes your NumPy available. Meanwhile, you must have an active internet network for the pip install to work. So I'll proceed it. I will run this cell. For me to run the cell, I'll use Shift and Enter or Control Enter. If you are using Mac, is Command Enter. Shift Enter executes the cell and creates a new cell below, but Control or Command Enter executes the cell and remain on that cell. So I import my NumPy. So let's start with creation of array and array. So we want to create array, and we can create array using, let me call this array equals to np dot array. If I do np dot array, then I'll specify. Now the arrays I want to create, I can put them in a list structure. So if it's more than a 2-dimensional array, it will be in this form. If it's more than a 1-dimensional array, it will be in this form. But if it's a 1-dimensional array, I have to use only one block brackets. So I can say this, I want to create an array of this. Then I will specify the data type for the array. So I'll just specify floats, or I can specify int for integer. When I execute this and I want the array to be printed, so I execute this and you see my array is printed. So I just created a 1-dimensional array. And from this creation, we can see that I can discover the shape of the array. I can use some other functions, some other methods. But before we start using the methods, I would like us to also create another array to explore the possible ways we can create an array. So if I say array2 is equal to np.array, this, creating a two-dimensional array. So the first dimension, I can do this. Then in the second dimension, I can also specify this. Now, this first block bracket is the first row. The second bracket is the second row. If I keep on adding, the rows keep on increasing. Now, the number of items, in a particular block constitutes the columns. So what I have now, for instance, is I have 1, 2, 3, 4, 5. Okay, let me make it 4, so that I will have a 3 by 4 array. So when I do this, I note that the data type most of the times is optional. It's optional. By default, it is none. So because Python automatically will pick the data type for you. So I run this. I said, okay, you should print this. Then when we have this, you see the array on your screen. It has been printed. The array on your screen has been printed. So, and you see this array is a 3 by 4 array. So to get the size, I can say arr2, which is the variable name, dot shape. The shape will give me the shape of the array. That is 3 by 4. Just like I said, it goes by rows, by columns. 3 by 4. Okay, I can do this to get the size of the array. The size of the array is different from the shape of the array. So if I want to get the size of the array should give me 12. Give me 12. So I can say arr2 dot size. Then I have 12, which means that array has 12 items in it. 12 items in it. Okay, so I can proceed by creating some other arrays, perform some other methods. Also, I can have arr2 dot, if I do ending, it gives me 2. That is the number of dimension. It's a two-dimensional array because it has the row and the column. A two-dimensional array. Okay, so this array, or what we call normally this, since it's a two-dimensional array, we call it a matrix. So this matrix has become can be transposed. The matrix can be transposed and can perform some other mathematical operations we do with matrix. So first of all, let me create. I have 2 arrays here. But I want to show you another way of creating an array. Please, if your side is noisy, you can mute it, please. Okay, I just mute someone that has a noisy background. Okay, so let me show you the other way we can create arrays. I can make an array arr3 because using mp.arange. Arange is a method that works like the range, the Python default range. So if I do mp.arange, I'm telling it to create an array for me, starting from a particular number to before the end of the number, and I can also give it a step. And if I so wish, I can include the data type. So if I want to create an array of numbers between 1 to 20 or 1 to 10, I can do this arange then, and I want it to have a step of 2. So I just specify this. When I run this, I can say my A, I can call it to get my array. So see, that is just an array. So if you know what you want to create, you can use a range to create it instead of you passing through the stress of creation. Another way we can create an array is using the random. So when I do np dot random, then I go deeper. I say rand int. If I say rand, I'll specify the dimension. If I say I want 2 by 3 array, so it will give me random numbers that have the shape of 2 by 3. So when I do this, you see the output on the screen. It gave me an array but with a random number. Okay, so what about if I want an integer, I'll say np dot rand int, then I'll specify the range. It will give me a value. It will return a value from this range. So I want a random number from 20 to, let me say, 30. 20 to 30. I run this, it gives me a random number. When I run it again, it will produce another integer for me that is a random number. These are some of the ways we can create an array. Another way, when we do np dot darray, np.array, that was where we started from. np.array, then we can do np.ndarray. This also gives us a random number. We specify the shape here. Let me say 3 by 3. We specify the shape, and also we can specify the data type. Okay, I want int as the data type. When I return this, it gives me random numbers, but they are all integer and the shape is 3 by 3. So these are some of the ways we can create an array or a matrix in NumPy. Remember, I started from saying we can create it manually by inputting the list. And whenever we are doing that, we should try and ensure that there is no null value when we are doing that. Okay, so we proceed to using some methods in NumPy. So some methods in NumPy, like I can do that's ARR array. This is our array. I can transpose it. I can say ARRT. When I transpose it, let me do it below. ARRT dot T. I transpose. It remains because it's just a dimension. But if I have two-dimensional array in the sense of ARR2 and I transpose it, I have ARR2 dot T. I transpose it, you see it change. What transpose does, it takes the columns and make them the rows. I take the rows and make them the column. Take the column and make them the rows. Take the rows and make them the column. Okay, so now some interesting thing. I'll be working with this array 2 a lot. So we can simply find the maximum, we can simply find the minimum, we can find the mean, we can find the median of what we have here. So I can say np dot mean, like if I want to get the mean, np dot mean ARR2 I execute it, it gives me the mean. It gives me the mean of this particular array. Then funny enough, I can say np dot np dot modes, the median, np dot median, that specify the array I'm looking for. I want to get the median. I execute it, it gives me the median. Now someone might be thinking that this is so big. Okay, let's make use of that first array and let's see, because we can easily calculate this and know what it will return. Okay, so we have np dot mean of arr. So it gives us 5.6. So if we scroll up, you can see this. When we sum this together and we divide by the number, which is the mean, by the frequency, you see we have what NumPy just gave us as 5.6. Looking at this, we say, okay, 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 7 is 19, 19 plus 9 is 28. So 28 divided by 1, 2, 3, 4, by 5. 28 divided by 5 will give you this 5.6. So it is easier to calculate that rather than stressing ourselves. Now, another good thing, you can do np.std. STD stands for standard deviation, STD of ARR, and we have the results. That is standard deviation, which is the how far or how close the difference between each and individual elements from the mean. So that is the standard deviation. We also get some other things like in this particular AR2, we can get the variance, we can get the correlation, coefficient. So I can say np dot call correlation coefficient of ARR2. You see it, and if you are conversant with statistics a little, whenever you perform correlation, you know each item is correlated to itself. So that's why you have that 1, 1, 1 as diagonal, 1, 1, 1. But other items, it finds the correlation between the other items. So that is for correlation and coefficient. Then you could do np dot covariance. I think that should be covariance. Sure. Covariance. Yeah, I got it. For the covariance, gives us the covariance. Now, so far we've been doing some methods. Now let's assume we have two different arrays or two different matrices. You want to join them together. You want to join them together to become one matrix. So let me assume this is A. Let me say A equals to np dot A range, np dot array. Okay. Okay, this is 2, 4. I have this 1, 3. Okay, that's my A, and this is my B. np dot array. I have 10, 12, 45. Then the next I have 5, 22, 19. Good. So store this array, so I can simply check for my arrays A. This is what A gives me. I can also check for my B. This is what B gives me. So I want to concatenate A and B together. I want to concatenate A and B together. So all I have to do, np.concatenate. I'll specify the arrays I want to concatenate, which is A and B. Then one thing that is important, I have to specify the axis. That is, am I concatenating by the column or am I concatenating by the row? When you are concatenating by the rows, that is, want to take B and append B to A so that the rows will be increased, then you specify the axis as 0, because 0 means axis of row. 0 as axis means row. Then if you want the columns to increase, you specify the axis as 1. So it will take the matrix B and join it side by side with A. So we'll go first with 0. Axis equals to 0. When we do this, that's only scalar can be converted to concats. So I will have to put this in parentheses, I think. Good. So I have this now. I have appended or I have concatenated. You see the columns, the rows increase, but the columns still remain 3. But the rows increase from 2 to 4. But if I do it the other way around, which is np.concatenate, and I specify my A and B, then I specify the axis 1, it means that take B and add it to A via the columns. So you see that the columns have increased. That is concatenation. And this will be done a lot when we start using Pandas, because you might be joining 2 data frames together, and also you might be creating new data frames. Okay, just like we have in Python, where you can append, when you can index in Python. Also in NumPy, we can index. Okay, this is our A, and this is our A. Let's assume we want to get the first element, the first item here. So remember in Python, we do this. When you do this, it returns the first row. It returns this first row. So if we get that first element, it has to be this. Then it gives you the first element. That's indexing in NumPy. It gives you the first element, because the first index, if it is 2-dimensional, it gives you the first row. If you specify 2 here, it gives you, if you specify 2 here, 1, sorry, it gives you this one, which means go to the second row and bring the first item. Go to the second row and bring the first item. So you do this, it gives you that particular sum. That's indexing in Python, in NumPy. How you can extract values. And in NumPy, this array A, if I want to make it flatten, I want to make it a one-dimensional array. All I have to do, I'll say np dot flatten no, a dot flatten, yeah. So since I'm making a to be flat, I do a dot flatten, not np dot flatten. A dot flatten. So it takes the two dimension of the shape and makes everything to be one. Is there any questions so far? Okay. Yeah. Okay, they are not related because concatenation, you are taking a matrix and you want to include it, you want to add it to another matrix, either by the column side, by column wise or by row wise. But flattening, we are taking a matrix that is having more than that is not a vector. That is not a vector. That is, it's not just one dimension. It's two dimension, and you want to make it a one dimension. That is flattening. So, like the example we showed above, if we do our A and B, this is our A, this is our B. Now, if we want to take A and add it to B, so what we'll do is np dot concatenate. Now, you have to know, are you concatenating it to increase the column or increase the rows? So if you want to increase the rows, which means that you say A comma B, you are adding B to A, but I want it to be added row wise. So it will change from a 2 by 3 matrix to a 4 by 3 matrix. So I can do that and say the row wise is 0. So when I do this now, I have 4 by 3 matrix. How do I know? I can do this and say dot shape. If I do dot shape, it tells me that it's a 4 by 3 matrix. But if I do this, remember, this is my matrix after concatenation. Then I do dot flatten. I do dot flatten. It will make everything to be one dimension. And after flattening it, I do dot shape. You see that I have just a vector. It's not a two dimension. If I do dots, this instead of dot shape, I do dot ending. Dot ending, which is give me the number of dimension. You see that I'll have one. I'll have one dimension. I don't know if you understood now the difference between both of them. Okay. Exactly, yes. Flatten takes it to one dimension. You're welcome.